Okay, folks, I am actually going to skip number 7 because I'm already getting tired. But it's the same idea here as the other problems, finding the sample size. Okay. So we're going to move on to number, oh no. We're going to move on to number 8 and 9. So number 8 and 9. Find the critical values Z alpha over 2. Or find the critical value T alpha over 2. So I'm doing one of the following. So you do one of the following. I don't want to hide this. Wait. What? Layer hidden. Oh, I'm on the wrong layer. Sorry. All right, so do one of the following. Or state that neither normal nor the t-distribution apply. So basically this is you checking your requirements. For distributions. So for number 8, you're doing a 90% confidence interval. N is 9. You know the standard deviation of the population is 4.2, and you're told that the population appears to be very skewed. So if the population is very skewed, the only way we could do this interval is if N is greater than equal to 30, or if it's normally distributed. Those are the only two ways we could use this this Z interval. We know it's we use Z alpha over 2 because we know this population standard deviation. So since it's skewed, very skewed, and N is not bigger than 30, we can't apply the normal or T distribution. So the answer to A would be C, right? Neither the normal nor the T distribution applies. Number 9. All right, so 90%, N is 10, is unknown. Population appears to be normally distributed. So since it appears to be normally distributed, the population, N can be less than 30. So that's okay. We know it's a 90% confidence level, but population standard deviation is unknown. If it's unknown, we have to look at the T distribution if sigma is unknown. So B, we have to find the critical value T alpha over 2. Okay, so if we have to find the critical value T alpha over 2, it would actually be pretty simple. We know we can look at table A3, and if N is 10, then we have 9 degrees of freedom. So the degree of freedom is equal to 9. We look at the table for table A3, to find T alpha over 2, to find your critical value. That's the only way to do it for this problem. So we look at the table, we go down to degrees of freedom of 9, assuming it's two-tailed, and we find that T is equal to 1.833. Let's get a good picture of that. Okay, let's make sure we're here. So we go to table A3. We go down to 9 degrees of freedom, 9 degrees of freedom, and we go over to two-tailed area of 0.1. How do I know it's 0.1 in two tails? Because it's a 90% confidence level. That means 10% is left. So I go down and go to 9 degrees of freedom, 1.833.